Scientists have created photonic time crystals that amplify light exponentially, which has tons of applications in quantum computing, fiber optics, and even imaging technology. And I know they are part of this article that says photonic time crystals is very intimidating, so I'm going to try to do the briefest and most practical explainer that I possibly can, which is that photonic time crystals are artificial materials whose electromagnetic properties are uniform in space, but periodically modulated in time. And the best example I can give of that are materials, particles, whatever. You'd probably see them in a chemistry textbook, bonded, something like this. They stay the same in space, but they do modulate. They wobble, they interact with the waveform in some capacity, and they have a temporal periodicity which generates a momentum band gap in which light exponentially grows, or if you're familiar with water hammer, or resonant sounds that shatter glasses, kind of like resonating with light, which creates exotic light, matter interaction, amplification of spontaneous emission of an excited atom, and tons of other things. So these are real particles, real artificial materials crystals, but they're sort of oscillating in time in a very unique way that amplifies light. If you can think about it as this is such a horrible analogy, how a magnifying glass focuses light and makes it more intense. This has a very similar effect of making light more intense without focusing it. It just generally amplifies it, which is very impressive. And the reason that this is important is that it allows scientists to create high efficiency light amplifiers and advanced sensors that have applications for laser technologies. And the reason this is important is because if you can amplify light, then you can have a lot of sort of transformative possibilities or upgrades in the fields of communication, fiber optics, internet, ethernet, all that stuff, imaging like MRI, CT scan, sensing, which I'll give you a good example of soon, and laying the groundwork for faster, more compact lasers, sensors, and almost every form of optical technology that we use. So what's really interesting about this is you can do things like, imagine we want to detect the presence of a small particle such as a virus, pollutant, or biomarker for diseases like cancer. When excited, we know the particle would emit a tiny amount of light at a specific wavelength. However, if this were done in a photonic time crystal, that could capture this light and automatically amplify it, enabling more efficient detection with existing equipment. So we can take existing lab equipment and make it way easier to detect viruses, particles, pollutions, all sorts of tiny little things. We can amplify the strength of a fiber optic cable. We can amplify signals in a quantum computer. Now, do keep in mind, this is in the very experimental, only exists in a laboratory phase right now. This is not an industrial technology that's being rolled out. They literally have like barely functioning experiments, but it is fascinating that we can amplify light, because if we can amplify light, there's a whole bunch of technologies that can get a lot more interesting.